Okay, so here's part B to number 5 because I ended that video a little bit too soon. But we're just still simplifying the trigonometric expressions, okay? So let's go to what we have here. Alright, so I'm adding or subtracting pieces right now that if I were to rewrite them as sine and cosine, I would have something that looks like the following. So sine squared over cosine squared, and this is 1 over cosine. So if you notice, you still have a common denominator of cosine cubed. Okay? And what we're doing is we're just trying to simplify this out. So because they're common, I can bring it all together as one huge fraction that looks something like this. And all I did was, because they were common denominators, I have them written there already, and I brought these two numerators together as 1. Okay? And we just talked about 1 minus sine squared, but we said 1 minus cosine squared as an identity over here would be sine squared. So guess what? If we move the sine over instead of the cosine, yes, we would have cosine squared is equal to 1 minus sine squared. So now let's go ahead and use this right now so that we can write this as cosine squared up top with that already common denominator of cosine cubed. Okay? So if we do cancel, it's like having x squared over x cubed. You would cancel and still have 1x on the bottom. That's what you're basically going to have here. You're going to have a cosine of x left at the bottom. Okay? Because again, it's like saying cosine squared and then cosine cubed on the bottom. So you have 2 up top, 3 on the bottom. Who wins? The bottom by 1. And if I simplify this out to have no fractions, I can rewrite it as secant of x, which is my final answer. Okay, so an easier way to do this, some people may or may not recognize this at the very beginning, is that whenever you have adding or subtracting trigonometric functions that way we were given, is that you could also GCF. I could have GCF'd a secant x at the very, very beginning by dividing it from both of these so that I would have a secant squared minus a tangent squared. Okay? And a secant squared minus a tangent squared is another form of manipulating one of these identities that is shown right here. Let me go ahead and find it real quick. So right here, if I were to move over tangent squared, I have 1 is equal to secant squared minus tangent squared. So secant squared minus tangent squared is what we have here. So it's like saying secant times 1, which is still going to be secant as your answer. So again, if you're good at manipulating the identities formula chart by moving stuff around, by adding or subtracting and or multiplying and dividing, you can get these identities a lot faster. Let's try that over here. Okay? So I have sine over cosine plus cosine, and it's being multiplied here with another sign. So here I don't have something that I could GCF out the way I had it over here, where there was something in both of the terms. And when I say both of the terms, I'm saying separated from addition and subtraction, we don't have something in both of them. Okay, we have a sine squared in the first, we have a cosine in the second, and then with this denominator piece, it's like we have a secant there as well. Okay? So what we would do here is continue with what we have and see if we could get, so we have sine over 1, so that we have sine squared over cosine plus cosine over 1. So there's no GCF going on here. We're going to get a common denominator by multiplying by a form of 1. Okay? So now this is common. So if I multiply just the top, we get cosine squared, we get sine squared from the very beginning, and we can bring it all together as one have my denominator common. Well, we know by now that, let me highlight it in blue so you don't get confused as far as where the cosine came from. From identities, we know sine squared plus cosine squared is equal to 1 up top. Nothing happened with the cosine. So this, simplified out, would also give us a secant of x. Because remember, when you are simplifying, you're trying to get something that does not have that fraction piece. And we're just going to say it as secant, cosecant, tangent, or cotangent, or any of those trigonometric functions as they are simplified.